Good day everyone, welcome for the new day of learning. I am Albert Tu-ayon and I will be discussing about the concept and the role of the proof. So please listen carefully and take down notes the important terms of my discussion because at the end of my discussion I will be given a short review to test yourself and to prove that you understand or listening of my discussion. So in this discussion, we are expected to understand the concepts and the role of the proof, and learn the most common types of mathematical proof, and relate and apply the importance in real-life problems and situations. So, what is proof in mathematics? So, what is the concept of the proof? So, a proof is a rigorous mathematical argument which unequivocally demonstrates the truth of a given proposition. So, a proof is a demonstrate about the truth of a given statement or theorem. So, it is a rhetorical device for convincing another mathematician that a given statement or theorem is true. So, a proof helps us to convince or to, to be confident to prove that that theorem is true. So, a theorem is a mathematical statement that has been proven. So, a theorem is a statement that has proven by any mathematical expert. So what is a concept of mathematical proof? So I have heard some example of mathematical proof. So a proof is an inferential argument for a mathematical statement, showing that stated assumption logically guarantee the conclusion. So this is the example of mathematical concept proof. So example, proving if A then B directly. So suppose that A then insert sequence of logical arguments here. So probably he will involve the definitions of the objects involved. So therefore B example prove that the sum of two odd integers so even. So for example, we are looking to add integers. So we add that two integers is the answer is even. So for example, we are going to look the two integers, for example, -1 and -3. So the sum of -1 and -3 is even. So which is -4. So next is also rewrite as f then statement and introduce the variable. So like for the example that I have mentioned earlier, prove that n and m are odd integers, then n plus m is even. So as I understand, or as we understand that we are proving that n and m are odd integers, so then n plus m is even. So for example that I have mentioned earlier, which is -1 plus -3 is equivalent to -4, which is even. So I have heard the three most common types of mathematical proof. So the first types is direct proof. Second is the proof by contrapositive and contradiction. And the third types is proof by induction. So we are going to define these common types of mathematical proof so that we are understand about this. So what is direct proof? A direct proof, it is used to prove that a statement is true using definitions and well-established properties. So the direct proof is about statements using definitions and well-established properties that prove that is true. So for example is we use it to prove statements of the form if P then Q, or P implies Q, which we can write as P implies Q. The method of that proof is takes an original statement P, which we assume to be true, and use it to show directly and another example Q is true. So for second is the indirect proof. So what is indirect proof? So it is instead of showing that the conclusions to be proved is true, you show that all of the alternatives are false. So this is the inverse of direct proof. If the statement is true, we prove that that statement is false. So To do this, you must assume the negation of the statements to be proved. So we are going to prove that statement that is false. Then, deductive reasoning. So we are going to apply that deductive reasoning will be lead to a contradiction, to statements that cannot both be true. So a contradiction shows that assumption made earlier is impossible and therefore false. So yes, that is right. And a contradiction, we are proving that that statement is true, but we prove that that is false. So thus, the statements to be proved must be true because its negation is false. So there are two types of indirect proof. First type is contradiction proof. So it is a form of proof that establishes the truth or validity of proposition. So by showing that assuming the proposition to be false leads to a contradiction. So for example, that suppose square root is 2 is rational, then integers a and b exist, so that square root of 2 a and b, it a and b, so a over b both multiples of 2. So this contradicts that the fact that we know a and b can be chosen to have no common factors. So the second types of indirect proof is contrapositive proof. So what is contrapositive proof? So it is a role of influence used in proof. So where one infers a conditional statement from its contrapositive. For example, I have an example which is our inverse statements would be, if it is not raining, then the grass is not wet. So our contrapositive statements would be, if the grass is not wet, then it is not raining. So this is the example of contrapositive proof. So what is a proof of induction? So this is the last types, the last common types of proof. So proof of induction. So it is just like an ordinary proof in which every steps must be justified. So it is also one of the most powerful methods of proof because it allows an observation of a single instance to be applied to all possible instances. So for example, proof by induction that n to the power of 2 is equal to n, where n is a natural number. So base case, so prove that it is true for n is equal to 1. So 1 to the power of 2 is equal to 1. So we can prove that n to the power of 2 is equal to n, where n is a natural number. So the first is induction step. So we assume that it is true for n is equal to r. So r to the power of 2 is equal to r. So now prove that it is true for r plus 1. So we are going to prove that n to the power of 2 is equivalent for n, where n is r plus 1. So r plus 1 to the power of 2 so is equal to r to the power of 2 plus 1 to the power of 2 is equivalent to r plus 1. So thus n to the power of 2 is equivalent to n holds true for r plus 1. So conclusion of these examples. By using induction, we have proven that n to the power of 2 is equal to n for all natural numbers. So as what we have examples above, we can say that n to the power of 2 is equal to n, where the n is all natural numbers. So this will end of my discussions, and the other topics of my discussions will be discussed of my partner Jairel Makasuhol. And thank you for watching, everyone, and I hope you learned something of my discussion. So listen carefully for the next reporter, so that you can answer easily a short review in the last discussion. So thank you for watching, everyone. Goodbye. Bye, everyone.
Good evening, everyone. This is the continuation report of Mr. Albert Tu-ayon. Three parts of induction proof. First, basis step. This is a property of a particular number of n that can be expressed as a function of that number, open parenthesis, p of n, close parenthesis. Number two, induction hypothesis. Here the hypothesis is made that p of n not only holds for the particular n of the basis step, but for all n in a given range, say n greater or equal to 0. Number 3, inductive step. This is where it is shown usually by substitution of open parenthesis n plus 1 close parenthesis for n in the function of p of n, or the addition of a open parenthesis n plus 1 term that the inductive hypothesis is true. Prove 1 plus 2 plus 2 to the raise of 2 plus 2 raise of n equals 2 raise of n plus 1 plus 1. For n greater equal to 0. Basis step, let p of n be the proposition that 2 raise of 0 plus 2 raise of 1 plus 2 raise of n equals 2 raise of n plus 1 minus 1 for n greater or equals to 0. Then for n equals to 0. So we need to change all the value of n in equals to 0. Because it becomes p of 0 into 2 raised of 0 equals 2 raised of 0 plus 1 minus 1 equals 1. In inductive hypothesis, given that p of n is true for some numbers n, assume that p of n holds for numbers greater than n such that p open parenthesis n plus 1 close parenthesis into 2 raised of 0 plus 2 raised of 1 plus 2 raised of n plus 2 raised of n plus 1 equals 2 open parenthesis raised of n plus 1 close parenthesis plus 1 minus 1. In inductive step, if the inductive hypothesis is true, then 2 raised of 0 plus 2 raised of 1 plus 2 raised of n plus 2 raised of n plus 1 equals quantity 2 raised of 0 plus 2 raised of 1 plus 2 raised of n close quantity plus 2 raised of n plus 1 equals quantity of 2 raised of 2n plus 1 minus 1 close quantity plus 2 raised of n plus 1, then equals 2.2 raised of n plus 1 minus 1, and equals 2 raised of open parenthesis n plus 1 close parenthesis plus 1 minus 1. Thus p of n holds for all n greater than equal 0. Why proof is important in mathematics? According to Blailer, Baxler and Pair 22, for a mathematician, a proof serves to continue or justify that a certain statement is true. It also increases the understanding of the result and related concepts. Proofs very often teach us deeper things about the nature of the mathematics with which we are studying. This helps to build our understanding and intuition about the mathematics. So why proof is important in mathematics? Because proof is explains how the concepts are related to each other. This view refers to the functions of explanation. Another reason the mathematicians give was the proof connects all mathematics. Without proof, everything will collapse. You cannot proceed without a proof. What is the role of proof? Proof exposes the underlying logical relationships between statements in way no amount of quasi-empirical testing nor pure intuition can. Proof is therefore an indispensable tool for systematizing various known results into a deductive system of axioms, definitions, and theorems. A proof is only meaningful when it answers the student's doubts, when it focuses what is not obvious. Klein 1973. Proof as a means of verification by George Polya. The inductive phase overcome our essential suspicion and gave us strong confidence in the theorem. With such confidence, we would have scarcely found the courage to undertake the proof which didn't look at all routine job. If you have satisfied yourself that the theorem is true, so you start proving it. Proof as means explanation by David and Hirsch in 1983. Although it is possible to achieve a high level of confidence in the validity of a confidence by means of quasi-empirical verification. Example, measurements, numerical substitution, and so on. This generally provide no satisfactory explanation why the conjecture may be true. It seems clear that we want a proof because if something is true and we can deduce it in this way, this is a sign of a lack of understanding on our part. Proof as a means of discovery. It is often said that theorems are most often first discovered by means of intuition and or quasi-empirical methods before they are verified by the production of proof. To the working mathematician, proof is therefore not merely a means of varying an already discovered result, but often also a means of exploring, analyzing, discovering, and inventing new results. So we have a short review in our previous discussion. Number one, a rigorous mathematical argument which univocally demonstrate the truth of a given proposition. Number two, a mathematical statement that has been proven. Number three, what type of proof that is used to prove that a statement is true using definition and will establish properties. Number four, it is a proof used when the direct proof is challenging to use. Number five, it is a type of indirect proof that establishes the truth or the validity of proposition. So please answer this following question and comment your answer in our Google Classroom. Thank you and God bless.